Hello and welcome again. In today's lecture, we will see some simple examples of Divisibility algorithm, and also we will see a remark which is actually another form of Divisibility algorithm. Okay, we start with some simple examples. The first example is that if b is equal to minus 11 and a is 61, then clearly we can write it this 61 is equal to minus 11 times minus 5 plus 6. If we see here, q is equal to minus 5 and r is equal to 6, and clearly this r is greater or equal to 0 but less than modulus of b. Modulus of b is 11. So it is clear that a and b can be written in the form of this by finding q and r. Okay, we move to the second example. This example states that square of every odd integer is of the form 8k plus 1. Here k is any integer. Okay, so we start the solution. Let n be an odd integer, and we have to show that the square of n is of the form 8k plus 1. Okay, since n is an odd integer, then n can be written as 2m plus 1, because n is odd integer, so it is not divisible by 2, so the remainder will be 1 whenever we will divide it by 2. So n is equal to 2m plus 1, where m is any integer. Now n square will be 2m plus 1 whole square, and that will be 4m square plus 4m plus 1. And if we take 4m as a common from first two terms, we will get 4m into m plus 1 plus 1. Okay, if m is an integer, this m is an integer, and then m plus 1 will be the consecutive second integer, and we know that the product of any two consecutive integer is even. Hence m into m plus 1 is even, because one of these two integer will be divisible by 2, because they are two consecutive integers. So their product can be written as there exists an integer which is k, such that this even integer m into m plus 1 will be equal to 2k. And if we put the value of m and m plus 1 here, we will get n square will be equal to 4 times 2k plus 1, and that will be equal to 8k plus 1, and that is what we want to prove. So square of any odd integer is of the form 8k plus 1. Okay, we move to the remark which I have already mentioned in the start of the lecture. This remark is: there is another version of division algorithm for integers a and b with b is not equal to 0, there exist unique integers q and r such that a is equal to bq plus r, and the variation of r can be between 1 over 2 mod b, r will be greater or equal to or strictly greater than this minus 1 over 2 mod b, but less than or equal to 1 over 2 mod b. Okay, for example, if a is 11 and b is 4, so we can have this 11 is equal to 2 times 4 plus 3. Here q is 2 and r is 3, and r is clearly less than b but greater or equal to 0. This is first form of the division algorithm, but this r is not between this interval, so we can have another representation, but we can see that in this form r and q are unique, but if we want to take r from this interval, then we will get another unique r. So this 11 can be written as 3 times 4 minus 1. Here q is equal to 3 and r is equal to minus 1, and clearly r is between this interval minus 1, and that is what we want to show. So that's the end of this lecture. If this lecture is interesting and clear to understand, then please like the video.